let's see what happens. So next slide. There we go. That looks good. On my end, I can see it. Okay, that's just a disclaimer. Next slide. Okay, so to what extent, so the question I wanted to ask is, to what extent do the probabilistic genotyping systems, true allele casework, and star mix provide consistent or inconsistent results, and why? Next slide. So comparisons between probabilistic genotyping systems assessing performance differences have been performed. This is just a handful of publications that I pulled up from a search, and I just want to point out none of these is with true allele. All of them are star mix or like LTD or Euroformix and so forth, but not true allele. Next slide. Now, we've had true allele in use for casework at the Virginia Department of Forensic Science since January of 2014 and star mix since 2021. And I wanted to perform this comparison to assess what differences in likelihood ratio results we may obtain because we expect differences, particularly with low template contributors, since true allele samples all the way down to 10 RFU or lower apparently, and star mix samples just according to each lab's analytical threshold. So I constructed mixtures specifically to target where I would expect to see substantial differences. So these mixtures, nearly every mixture contained at least one contributor that was less than 100 picograms, and most of those low template contributors were less than 50 picograms, so they were very low template. Next slide. So before I get into this a little bit more, I just want to point out some of the most obvious dissimilarities between true allele and star mix. Next. True allele uses the raw HID or similar CE files, as we all know. Next. Apologize for all of this, but star mix requires use of GMIDX or some similar intermediary program, and so it accepts edited .txt files. Next. True allele, the baseline noise is modeled by the software de novo on a per locus basis, whereas next, star mix uses the lab-specific analytical threshold that's applied in GMIDX. Okay, next slide. Some additional dissimilarities. Next. True allele does not apply a dropout factor. As you know, all possible genotype combinations are assessed for every locus. Next, star mix uses a Q placeholder for a possible dropped allele because it does not see what's under analytical threshold. So the dropped allele could be any allele. And the probability of the dropped allele is calculated during the MCMC iterations. Next. Star mix assesses all the peaks below the lab-specific drop-in threshold as possible drop-in. For example, in our lab, it's 150 RFUs. And the frequency matters because the frequency is low for dropped-in alleles. And so it's not going to accept a lot of data that has peaks, additional peaks beyond what your contributor number would imply. As you know, true allele uses no drop-in factor, and an unaccounted for allele will be modeled as any other allele and may increase uncertainty at that locus. Okay, next. So I created challenging Powerplex fusion profiles. This is Fusion 5C. 18 two-person, 18 three-person, next, and 12 four-person. Next. 46 out of the 48 mixtures had one or more low template contributors below 100 picograms. Next. And 35 of the 46 contained one or more very low template contributors less than 50 picograms. And then next. And 37 out of these 48 mixtures contain one or more degraded contributors. And these varied from extremely degraded, where there's a severe ski slope with higher molecular weight loci typically dropping out, versus just a ski slope, a pronounced ski slope, and not necessarily drop out of the large molecular weight loci. Okay, next slide. So the differences for the purposes of this study, and it's in line with our lab criteria for drawing conclusions, were the differences in likelihood ratio results were categorized. And it was categorized as no difference in the log LR results if next. Both log LR results per contributor, log LR results for both TrueAllele and star mix were greater than 3, or 1,000 times more likely. And that's regardless of the magnitude, because it's supported an inclusion. If both log LRs fell within plus or minus log LR3, that's supported inconclusive as defined internally in our lab. And if both were less than -3, which supports an exclusion based on our criteria. So it was categorized as a difference if next one system supported an inconclusive and the other an inclusion. One system supported an inconclusive and the other an exclusion. And if they were actually contradictory, where one supported an inclusion and the other supported an exclusion. Okay, next. So just briefly, materials and methods. All the samples were purified using DNA-IQ. They were quantitated using either Plex or HY or PowerQuant. They were typed using PowerPlex Fusion with a target of 0.5 nanograms. We used half reactions and a lower cycle number. And they were separated and detected using 3500 XL. Star mix and TrueAllele were used as recommended and described in our standard operating procedures, which are all available to the public and published online. So the data analysis was performed just using Excel. Okay, next slide. This graph is just showing you the wide range of contributor-specific template quantities tested. These are extrapolated from each PropGen system's proportion estimates for the contributor proportions, and based on our target input, template input. And so on the y-axis, the estimated contributor template quantity in picograms, and then without labeling each are just the different contributors to the 2, 3, and 4 person mixtures. Star mix is in orange, TrueAllele is in blue, and that's going to be throughout this presentation. Star mix will be in orange, TrueAllele will be in blue. And the take-home message here is that a wide range, really like pretty much the total range between 500 and 0 picograms were tested. Okay, next slide. So this was comparing the contributor-specific template estimates generated by star mix, shown on the y-axis, and TrueAllele, shown on the x-axis, and this is all in picograms. And then the R-squared was calculated, and linear regression performed R-squared calculated, and so the 2-person mixtures are shown in blue, and the R-squared was above 94%. 3-person in orange, and the R-squared was above 94% again. And the 4-person, the R-squared was a little bit lower, about 70%, and it's shown in green. Next, I just wanted to point out that you can see that the points cluster at the more extremes, really the low template and the higher template, and it's kind of in the middle range where you see a little more dispersion from the regression line. And I think that's not so surprising because it's harder to estimate contributors, or there's more variability in that 30% versus a 40% contributor and so on. Okay, next slide. So a high correlation when looking at these are all the mixtures tested and all the contributor-specific log LRs compared between star mix on the y-axis and true allele on the x-axis. And so I just wanted to point out the R-squared up above next is above 88%. You can see there is some deviation from the regression line. And then next, I performed a t-test. I believe it was an unpaired equal variance t-test, and with an alpha 0.05, and you can see that it's low, but it's still coming back as no statistically significant difference. However, next slide, when I parse out and just compare the log LRs for contributors of 100 picograms or less, again, the same setup, star mix, log LRs on the y-axis, true allele on the x-axis, you can see that the R-squared next drops to 68%, and then the t-test, that value clearly shows that there's statistically significant differences. Next, you can see it's 0.0007. Okay, conversely, and not surprisingly, on the next slide, when I just look at the contributors that are above 100 picograms and compare those next, the R-squared's above 89%, and there's no statistically significant difference next. Okay, next slide. So let's just look at the actual log LRs generated. The log LR values are shown on the y-axis, and these are two-person mixtures, and all the mixtures are listed on the x-axis with, contributor 1, contributor 2, contributor 1, contributor 2. Again, star mix is in orange, true allele is in blue. Now, you can see that they really track pretty well with each other than some differences in magnitude. Again, just a reminder, our inconclusive zone or uninformative zone is plus or minus log 3. Now, the arrows point to two contributors that show a difference in result as defined for this study and actually by our lab interpretation criteria. And you can see mixture 2, 5F, the lower template contributor shows a very small but positive log LR for star mix, and it's in the inconclusive range for true allele. And then mix 39F, the low template contributor, shows inconclusive range for star mix and slightly in the negative exclusionary range for true allele. Okay, next slide. Here's data for three-person mixtures. Same setup, contributor-specific log LRs on the Y and all the mixtures listed below with their contributor-specific log LRs on the X. And so next, these arrows are pointing to two contributors that are showing a difference in the log LR. So mix 37F, this lower level contributor, is positive in the positive inclusionary range for star mix and inconclusive for true allele. And then mix 344F is inconclusive for star mix and slightly exclusionary for true allele. And then next, mix 345F. This is one of the examples that was truly contradictory. It's just barely in the inclusionary range, just barely above log 3 in star mix and just below log -3 for true allele. Okay, next slide. One point to make is mix for this really low template contributor for mix 330F. they had nearly identical values. Now, the most likely reason for that is for mix 37F and 44F and 44F and 45F, that low template contributor was also degraded, very degraded. Whereas for mix, that is mix 30F, the low template contributor is not degraded. Okay, next slide. So for the 4-person mixtures, you can see there's some much more dramatic differences and more, a greater number of differences. So next, this first group of arrows is just pointing to lower template contributors where there is a difference. For mix 4F, there's one of the lower template contributors, true allele, was in the positive log LR range, and star mix inconclusive. And then for a different contributor, then star mix was inclusionary, true allele inconclusive. And that was the same finding for mix 4-5F and mix 4-9F. Now, the next set of arrows are pointing to some of the mixtures that I analyzed a little bit more in depth, and I'll address that a little bit more later. But these were bigger differences, really substantial differences in magnitude of the log LRs and the results. So for mix 16F, mix 416F, the lowest template contributor came back in the inconclusive range for star mix but with true allele, it was a very large negative log LR, more negative than -12. For mix 419F, the lower template contributor came back with about 1 million times more likely log 6 for star mix and nearly a log -9 for true allele. And we'll come back and go over that mixture, mix 419F, in a lot more detail here momentarily. Now for mix 21F, again, this lower template contributor, big difference. Star mix came back with an inconclusive range log LR, whereas true allele was approximately -9. And then mix 22F, star mix, slightly negative inconclusive value, true allele approximately -6. And then for mix 23F, which I'll talk a little bit more about that mixture later, star mix generated a log LR of 9, or 1 billion times more likely, and true allele came back with a small inconclusive but negative log LR. All right, next slide. So 14 out of 152 contributor-specific log LR comparisons showed differences. That's about 9%. Next. 12 were differences between an inconclusive and an inclusion, or an inconclusive and an exclusion. Next. And 2 were differences between an inclusion and an exclusion. So we're going to examine in detail differences in the analysis of mix 419F. But first, I want to show you some other data that's of interest. Next slide. Oh, sorry. Before that, I wanted just to point out a couple things. This is just a blow up of the histogram for mix 419F. And you can see for the other contributor log LRs, again, star mix is in orange, true allele is in blue, their values aren't that different. But the one lower template sample, which is rib bone H, star mix came back with 1 million times more likely. True allele was almost 1 billion times less likely. It's a very degraded DNA sample, True allele estimated at about 106 picograms, and star mix at about 40 picograms. Okay, next slide. This is the electropherogram for mix 419F. I know there's a lot there, and we don't need to look at every detail, but the circles, the black circles, are indicating the alleles that are consistent with rib bone H. And when that circle's at the baseline, it means that allele's not present or the peak's below analytical threshold. So next, there are actually 9 alleles missing for rib bone H that are not labeled. 7 of those, there is nothing there. There's no evidence at all of that allele present. And so just to prove that to you, go to the next slide. And this is a blow up of the blue channel. And what you should be able to see is that red arrow, the circled alleles in gray in this figure are consistent with rib bone H. Where the red arrows point is where the allele, an allele for a heterozygote genotype at that locus, or for rib bone H, is not present. It's not visible. There's nothing there. So next slide. This data table kind of is giving you some details about the electropherogram, rib bone H, and true allele and star mixes, log LRs, per locus log LRs. And under EPG notes, which is kind of in the middle, for each of these loci, which are listed there on the left, rib bone H genotype you can see is the column right there where Matt has the cursor or the arrow. That shows you the genotypes at all the loci for rib bone H. So the electropherogram notes point out at each of the loci where there's either the allele is not visible at all or it's below analytical threshold. And what you should be able to notice is where that allele is not visible, there's nothing there, that's where true allele comes up with a much larger negative value. It's more negative. Star mix is either a positive log LR or just slightly negative. So next, just to draw your attention to one locus that I'm going to focus on is TPOX. So at TPOX, the rib bone H genotype is 911. There is no 9 visible, and the 11 is a shared allele. True allele came back at that locus with minus 2.0, and star mix came back with a log LR of minus 0.04, just barely negative. So let's go to the next slide. Okay, this is where I deviate into something related, and then I'll come back to the TPOX locus in mix 419F. So 7 of the 14 mixtures that I showed you before, showing the largest differences in contributor-specific log LR between true allele and star mix were reanalyzed using a 10 RFU analytical threshold in GMIDX and reanalyzed by star mix. I manually edited out the baseline noise, and I could do that because I knew what the genotypes were for all the contributors. This isn't validated, and it's not suitable for forensic unknowns because you don't know what the genotypes for all the contributors to that mixture are. So, but the point is to give these two programs more similar genetic data instead of them viewing and analyzing different data, which is actually what they do, even from the same mixture. So next slide shows you the results of this. So the contributor-specific log LRs are listed, those values are listed on the y-axis, and the different mixtures are listed down below with, contributor 1, contributor 2, or 1, 2, 3, or 1, 2, 3, 4. Star mix with our normal, the analysis done in GMIDX with our normal analytical threshold is set at 75 RFU. That's in orange. Star mix using data using a 10 RFU analytical threshold is shown in green, and true allele is shown in blue. So next, the arrows point to all of those contributor-specific log LRs that change dramatically when the star mix data was analyzed at 10R, using a 10 RFU analytical threshold. All those log LRs shifted from being, most of them being positive, a couple were inconclusive, to being much more similar to the true allele values. And if you look at mix 419F, shown with the black arrow in the center, that log LR switched from being 1,000,000 times more likely to being about 1,000,000 times less likely, and very similar to the true allele value for that contributor. If you look to the right of that, for mix 21F, that value went from being in the inconclusive range for star mix to being 0, which means for their system, it eliminated that contributor completely. So it's a complete elimination, and that's certainly in line with the true allele data. And then I just want to draw your attention to the far right for mix 423F. That one I pointed out earlier, where the value for that contributor was 1 billion times more likely. Now, analyzing that data at a 10 RFU analytical threshold, now it's 1,000,000 times less likely. It's even a little bit lower than what true allele generated. Now, for two of the mixtures, mix 239F and mix 422F, the log LR for star mix actually increased, and for mix 239F, it became slightly inclusionary, just above a log 3. Okay, next slide. Now back to TPOCs. This is for mix 419F, that rib bone H. So this top panel shows the genotypes and the weights or probabilities that star mix generated, the whole listing, when that mix 419F was analyzed using our standard RFU of 75 for the analytical threshold. And what you can see next is, remember, rib bone H is a 911 at TPOCs. So it's got the Q placeholder and a Q11, and it gave it a probability or genotypic weight of 8.79%. Okay. Now, when reanalyzed at a 10 RFU analytical threshold, and then analyzed by star mix, now next, that Q11 genotype becomes much, much, much lower. And now it's 0.24%. And as you can see by this table, the listing of possible genotypes to explain that data is much expanded, right? It's a much more uncertainty at that locus when more of that data were modeled. And next, I just want to point out that now the genotypes with the largest weights or probabilities have a 5 allele associated with those. So next slide. If we take a look at that locus blown up a little bit, you can see there's a 5 peak in the stutter position, and there's also a 10 allele in the stutter position. So next. And then there's nothing, of course, for the 9 allele, nothing at all there. And next, that stutter threshold then for 5, I mean, the measured stutter is 10.3%, which is far above TPOC's stutter threshold. So it's not, it makes some sense to model that 5 as potentially a real, allele. And then the 10 is only 4.5%. Now, at 75 RFU, the lowest template contributor for star mix was estimated at 8%. But at 10 RFU, the lowest template contributor was estimated to be 1%. So it really changed the analysis that star mix performed when it saw all that low template data. Okay, next slide. So in conclusion, next, star mix and true allele were interrogated with 48 challenging mixtures. Next, the results for true allele and star mix were consistent in 91% of contributor comparisons as defined in this study. Next, differences in modeling allelic dropout can create large differences in log LRs for low template contributors, especially when there's excessive dropout or when the allele is not observed at all. Next, the contributor-specific log LRs showed a general correlation with template quality. And next, 7 of the 14 mixtures that produced a difference in result were reanalyzed with star mix using a 10 RFU threshold. And 5 of those 7 showed a negative log LR similar to true alleles. One was just a complete elimination with a combined likelihood ratio of 0. And 2 showed a small increase with 1 changing from an INC to small supportive log LR. And only limited conclusions can be drawn since this is not validated at 10 RFU and the modeling variables were not optimized. Next, and that is where I'll leave you. And so if you have any questions, I would love to take them now.